Imagine processing thousands of scanned invoice barcodes in under a second without installing bloated third-party libraries. Today, you'll learn how to build a pure Python automation script to extract, validate, and parse barcode data instantly. Welcome to this hands-on Python screencast on automating barcode and QR code data extraction. In many automated workflows, scanned documents or inventory logs arrive as image files or raw byte streams. Instead of manually decoding them or relying on heavy external dependencies, we can leverage Python's built-in standard library capabilities, data structures, and regular expressions to parse, structure, and store scanned payload information efficiently. By the end of this tutorial, you'll have a robust, reusable pipeline script ready for production. Before writing code, let's map out our automation pipeline. Processing scanned codes requires a structured approach divided into clear stages. First, we ingest raw simulated scanner outputs or image byte buffers. Second, we decode the encoded payload representation. Third, we validate the data format against expected schema rules like serial numbers or product SKUs. Finally, we output clean structured records into standard formats like JSON or CSV for downstream systems. This modular layout ensures that our script remains maintainable, testable, and easy to extend as business requirements evolve over time. Let's start by writing our first complete and runnable Python script. Since we are using standard library tools only, we'll simulate an incoming batch of scanned barcode byte streams directly in memory. We'll define a list of raw byte strings representing various products, shipping containers, and identification badges. Then, we iterate through each item, decoding the byte strings into standard UTF-8 text so our subsequent processing steps can inspect the payload safely. Hit Run to see how we ingest the raw data stream. Once we have our decoded strings, validation is critical. Scanners often capture noise, truncated codes, or corrupted payloads due to smudged labels. We need a strategy to filter out bad data before it pollutes our database. Using regular expressions from Python's re module, we can define precise patterns for valid barcodes, separating them into distinct categories such as inventory SKUs, invoice markers, and personnel badges. Invalid strings are flagged immediately, ensuring downstream automation tasks never crash due to unexpected formatting errors. Let's update our script to include robust regular expression validation. We'll import the built-in re module and compile pattern matchers for our SKUs and invoices. As we process each scanned item from our simulated stream, we test it against our compiled patterns. If a match is found, we categorize it and extract specific subgroups, otherwise, we log it as an invalid scan. This pattern matching guarantees high data integrity without needing external validation packages. Now that our payloads are validated, we need to parse them into rich data structures. Barcodes and QR codes frequently pack multiple data fields into a single delimiter-separated string, for example, combining a product identifier, batch number, and timestamp separated by pipes or colons. We can use Python's built-in string splitting and dictionary mapping to transform these flat text strings into deeply structured Python dictionaries, making them ready for programmatic analysis or report generation. In this code example, we simulate a more complex QR code payload that encodes multiple data attributes separated by vertical pipes. We write a parser function that splits the string, extracts each attribute into labeled dictionary keys, and handles malformed strings gracefully using try-except blocks. Running this code demonstrates how raw scanned strings transform instantly into clean, structured dictionaries suitable for database insertion. Extracting data is only half the battle. We also need to automate how this information is stored and shared. In enterprise environments, extracted barcode logs are typically exported into standard interchange formats like JSON or CSV. Python's built-in JSON and CSV modules allow us to serialize our structured dictionaries directly to string buffers or files without any external dependencies. This ensures seamless integration with spreadsheet applications, logging services, or cloud data warehouses. Let's tie everything together into a complete automation script that ingests, validates, parses, and exports our scanned barcode data. We will use Python's built-in JSON module to format our processed records into a pretty printed JSON string, and the I/O module to simulate writing CSV data into memory. This self-contained script represents a fully functional, production-grade extraction pipeline using only standard library features. When scaling your barcode automation scripts for high-volume operations, resilience is paramount. Scanners can drop connections, files can become locked, and corrupted inputs can appear unexpectedly. Implementing comprehensive exception handling, retry logic, and fallback logging ensures your automation runs smoothly overnight without manual supervision. Designing your pipelines defensively protects your data integrity and provides clear diagnostic trails whenever anomalies occur. Congratulations! You've successfully built a complete, pure Python automation pipeline for extracting, validating, parsing, and exporting scanned barcode and QR code data using only the standard library. You've learned how to ingest byte streams, apply robust regular expressions, structure complex delimited payloads, and format outputs into standard JSON and CSV formats. You can now take these patterns and integrate them into your own enterprise automation workflows. Thanks for watching, and happy coding!